Hello, my name is Katia Jamat, and today I will be going over my classification model for air currents over North America. I actually used a preloaded data set that was inside of MATLAB already, which is wind.mat, and the evaluation techniques that I attempted are decision tree, which is a classifier based off a series of decisions, and it's visualized in a tree. It's commonly used. Logistic regression. This is going to be a different type of evaluation where we estimate the probability of an event occurring. The random forest classifier is going to make predictions based off of patterns of the data rather than explaining the relationships between the variables. So the data set that I used is 3D data on air currents over North America, and it consists of XYZ position components and UVW velocity components, which I tried to compare. The file size is 142 KB. The data size is 6 matrices, the size of 35 by 41 by 15, which is very large. And we're going to try to kind of narrow that down into a controlled area, which we'll see in the demo. The classification models that I attempted to use, I didn't use all of them. Logistic regression, decision tree, SVM, and random forest. So SVM was one that I took out. I did not use, but you will see. And so that is something that can be an enhancement in the future if it is a better technique. Data pre-processing. So the most challenging step of this project was checking and removing for missing data. Uh, you'll see in the demo that not optimizing this step is going to give me an ill-conditioned X training set. And if I have that, then that is not going to allow me to evaluate my predictions properly. It's going to let you know your predictions may not be as correct as you would like them to be. So after we get past that, after we get past the obstacle of removing data, we're going to normalize it. And then we're going to split the training sets into two: 70% training and 30% testing. So during the train and evaluate section, as mentioned before, these 3 techniques I implemented, and we are going to evaluate each of these based on accuracy, precision, recall, F1 score, and this acronym ROC AUC. So ROC is Receiving Operating Characteristics Curve, which is a evaluating tool for performance used in machine learning models. AUC is area under the curve. So the full acronym, Receiving Operating Characteristic Curve, area under curve. So as I mentioned, I ran into a couple of errors when I tried to use parameters that took out the information that was NaN that may have been irrelevant or redundant. And so the result of that is this particular parameter does not support ND arrays. As I mentioned before, I'm using 3D arrays, and this caused an issue that I had to mitigate. So my first step was commenting it out. That didn't work. And it gave me this error message. It gave me an error message that said G and G hat need to be the same type. What does that mean? That's group and group hat. That's basically telling me that I have 2 different types of data, whether it be classification and binary, whether it be the size of data. I need to figure out how to evaluate what I have based off the data so that they can match correctly in my evaluation model function. How can I do this? I attempted to evaluate this in three different ways. For logistic regression, I converted the probabilities into binary labels. For a tree and random forest, we have to ensure that's the same size, right? So I did a display to where I verified that those were the same size, and then also did a display to determine if any of the data inside of this data set was categorical, right? Because I know I'm working with numbers, so if I have anything that's a category, that's gonna throw me off. If I have anything that's a character, not a double, it's gonna throw me off. So the expected results for for one of the evaluation techniques, the logistic regression, using this confusion model would be this here: accuracy at 90%, precision at 92%, recall at 85%, F1 score at 88%, and AUC at 94%, or 0.94%. Excuse me, point before all of those. I said that wrong. Uh, For the decision tree, it was very similar. Actually, the accuracy, the expected results for the decision tree were very similar. The difference was the AUC, which was 0.98. Now, the actual results is what we have here. We have an ill condition X, and that is causing problems in this regression. It's causing problems in this machine learning model to make a decision. And so these steps here are my attempts to verify that things are similar, right? The size of the Y test, size of Y predict. I'm looking to see what are the first few predictions. What's actually happening in here? And it's right. It's telling me these are those zeros. These are those zeros. We don't want that. We want to take those out. Okay, so conclusion to this technique to improve this classifier, some techniques would be improving the decision tree, pruning it, right? Taking out maybe decisions that don't need to be made, which is those zeros. We need to take that out. We need to find, or I need to find a parameter that will allow me to manipulate ND arrays. Once I'm able to do that, then I can get into more feature engineering, right? Removing more redundant or irrelevant features that may not be relevant to what I'm trying to compare. Further enhancement to this would be taking that information now from the feature engineering and using hyperparameter tuning to set the limits, right? So now we have max depth. We can set a minimum sample amount of splitting the data, right? How many times are we going to split this data? We can set max features, and this is going to enhance our decision making. So let's get into our 5-minute demo. Here are the citations. I use mostly MATLAB help links in the Help Center. Here you will see the loaded data that I was talking about, the WIN data set. We're going to load in win.mat. And I wanted to take a look at the data because it was a very large file. And so I displayed the first 8 rows of the matrix X, Y, and Z. And then I summarized it, right? So that's going to give me the min, the max, the mean, standard deviation of all of those rows. And it's 8 rows. Let me go all the way down. Oh, here we go. Wrong section. And here's the summary. And it's also going to give me standard deviation and the numbers missing, right? This is the key issue, as we will see as we move forward. But before we get there, we want to, in summary of all of the sections. Okay, so now we're going to visualize the distribution of velocity across the different positions. Okay, so this right here will allow you to have a visual representation of position versus velocity. I'm getting into my data pre-processing step here. This is where I did a lot of my trial and error. So I was able to pull out the the parameters, right, that had zeros. Is nan and y and x. And my attempt here to remove the rows that contain missing values is where you are going to see that error message that I displayed in the presentation, right? It does not support in arrays. So how can I mitigate this? My first step was to take it out. So let's take it out. And let's run it again, see what happens. And something does happen. Gives me another error message. It keeps going. It keeps trying to train itself, but then it says, you know what? This is ill conditioned and I don't think that you should move forward. So what I did was add in some checks for myself because this was not here before. So some of the checks that you can see, or let me go back. So after that, I normalized the information, or normalize X, even though, and that's why I'm still trying to train, even though it's not great, I'm still normalizing it. And then I train it here. I partition it and I have my XY train and my XY test to evaluate against each other. Okay. So this first training classification model, I'm evaluating the performance. And then you see here, I convert the probabilities to the binary prediction. That's my first attempt to make sure that the data is correct, that it is consistent. Here, now we're going to ensure that the Y-test and the Y-pred logistics are both binary. And remember, this is just for one evaluation model. If I was looking at decision tree or RF model, then this would change. The Y predict logistics would be Y predict RF and decision, or Y predict tree, and so forth. But so checking for the size here, checking the size of the prediction, and then also checking to see if it's the same data type, right? And so I was able to put those enhancements in here. But the biggest thing that is leading me back or holding me back is this RM missing. Being able to exclude these RM missing is going to enhance this X, will allow me to have a better evaluation. But going into the evaluation of these methods and the metrics that I use to evaluate it, here's my confusion matrix. And this is where the error message hits. It's gonna run into some backcode that says, yeah, this is mismatch. I don't like this. And that's just going to be maybe new things that I need to add, or I wasn't sure. Accuracy, we're gonna determine that. Precision, recall, and F1 score. And then here is our determination of our ROC. And because it is a binary class, we want to have that area under the curve displayed. And here are the functions for each of the evaluation models. And as I said before, we did not use the SVM model. We only used logistic, decision tree, and random forest classification. And that concludes my presentation. Thank you.